Hi, I'm Ayushi. In this video, I will walk you through a data drift monitoring framework and a lightweight React frontend I built to interact with it. We'll upload two CSV files, run both standard statistical drift checks and AI embedding based drift checks, and inspect the results side by side. My goal is simple: show how to detect when your data changes in a way that could break models or data pipelines. I'll demonstrate the UI, run a live example, and then do a short code walkthrough so you can reproduce everything locally. Quick architecture is as follows. So there's a Python Flask backend. So this is the Python Flask backend that houses drift detection modules. Like schema checks, categorical and numerical tests, null value monitoring, string pattern checks, and an AI drift module that uses text embeddings. The React app uploads two CSVs to this backend and renders the result in a friendly way. So here's how the flow will look like. We upload a reference CSV and a new data CSV. The frontend will call the backend API twice, once for standard drift and once for AI drift. And then we'll view both of these reports side by side. You can also select a mode and download the JSON result. So let's look at this UI in detail. This is the upload card. It's intentionally simple. Two file inputs, one for the reference CSV and the other one for the new CSV. After selecting both of these files, click Upload and Analyze. And while the analysis runs, the button shows a loading state. There's a basic error handling if we forget a file or in case the backend fails. Alright, so now I'm going to upload two example CSVs. The reference file here represents the historic data the model was trained on. The new data file represents a current batch we want to monitor. Now let's click on Upload and Analyze. You will notice the app runs two requests in parallel, one for the standard drift and other one for the AI embedding based pipeline. So this gives us both a statistical and a semantical view of the drift. So while backend analyzes the file, you will see the analyzing state in picture, and when the results return, we display them right here. By default, both the standard drift and AI drift results show side by side, so you can compare them quickly. Now let's inspect the standard drift report in detail. The drift analysis result component renders section only if they exist. Here we are seeing firstly the categorical drift, where we talk about the distribution changes, the changes in p-value, or any of the flagged columns. Then we have the numerical drift, which will also talk about changes in mean, variance, or distributional test. But then this section, there was no change, which is why it was not rendered. Here now we have the null value drift, where we can see any changes in missing value percentage. And then there's schema drift, which talks about added, removed, or type changed columns. At last, we also have string pattern drift, which checks for formatting changes or any pattern violations. Now let's go ahead and view the AI drift analysis results. This is embedding based and meant for text or semantic checks. The UI lists columns with embedding similarity and a drift detected flag. For each text column, you'll see an embedding similarity percentage. Lower similarity suggests a semantic shift. If you prefer to focus on just one analysis, then use the drop down to select standard or AI mode. When a mode is selected, the app shows only that report and enables a download result. This result saves the JSON to your machine. Here I have selected the AI drift analysis, and I can also click on download to download this JSON file. Now let's go ahead and do a code walkthrough. Now let's start by walking through the front-end part of the code. So this is the source component's file upload.js. It uses two local states for each file and handle upload that validates selection. We run two upload calls in parallel using promise.all, and this helps us get both the non-AI and AI results. On success, we call onUpload success with both the results so the parents can display them. Now let's go ahead and review the source component's drift analysis result.js. So here there is a reusable section component for UI consistency. The render AI drift table will handle both object detailed rows and string fallback messages. And this will also format any embedding similarity as per the percentage. The render table recursively renders nested objects into the tables for schema drift, categorical summaries, and more. The component detects, and then the drift analysis result component detects AI mode either by checking for keys that end with embedding drift or by an AI embedding drift object in the result. So the front end calls the back end twice via source services API.js. This uses Axios and constructs a form data payload. The app reads React App API URL from the environment. By default, it falls back to the local host 5050. And if you make any changes to your backend port, you also need to update the environment in the React app here. Now, if you want to run this locally, here are the steps. So first, you need to run pip install requirements.txt, and then you go ahead and run the source main.py file. This starts the Flask API. The default port in README is 5050. For the front end, the steps are as follows. First, we need to change directory to React Data Drift app. and then we run npm install and then create .environment with React App API URL is equal to localhost 5050 and then run npm start and finally open localhost 3000. So this is how the backend files look like. So here the AI-drift.py uses sentence transformer and we use a model called AllMini. We have the categorical drift file where we are looking for any p-value changes, any changes in the counts, etc. We have the null value file which detects any changes in the null values. Then the numerical drift file which detects changes in the statistical values of the data. The schema drift file checks for any addition or deletion of the columns. And then we have the string pattern drift file where we detect for any pattern changes in the string. So I have uploaded both the backend and the front-end code here in GitHub. So this is the front-end code and this is the file for the backend code. Please feel free to clone and run it in your system.